The figure which you are seeing in this video is actually a Venn diagram. So in today's video lecture, we are going to see the types of Venn diagrams in sets. This video is going to be very interesting, so please continue watching till the end. So basically, what are Venn diagrams? Venn diagram is also called as Venn-Euler diagram, and it is a way of representing the relationship between sets. If we want to say what is the relationship between 2 or 3 sets, we can represent that with the help of Venn diagram or Venn-Euler diagram. For example, bar graph is used to represent some data. Similarly, in order to represent the relationship between sets, we use Venn diagram or Venn-Euler diagram. Now, this Venn diagram, they consist of rectangles, and they are also drawn by using some closed curves like circles. So let us see how they are drawn with the help of rectangles and circles. First one is universal set, which is represented by the symbol mu. A set which consists of all sets under consideration and is denoted by mu. Okay, this is called as universal set. It means that, for example, we know in number theory, the highest is real numbers, right? That is this rectangle. In this one rectangle, we are having second rectangle. Then in second rectangle, we are having a third rectangle. And in the third rectangle, we are having a fourth rectangle. Then finally, we are having a fifth rectangle. Okay, it is not a puzzle actually. It is in R here is real numbers. So in real numbers, you have integers, and in integers you have in real numbers you have rational numbers, and in rational numbers you have integers, and in integers you have whole numbers, and in whole numbers you have natural numbers. That is, natural numbers start from 1, okay, whole numbers start from 0. So natural numbers are a part of whole numbers. Similarly, whole numbers are a part of integers, and integers are a part of rational numbers, and rational numbers are a part of real numbers. That is, real number is comprising all the type of numbers. That is why real number can be categorized as a universal set here. That is, real number can be categorized as mu. That is, when we consider one particular set is consisting of all the elements, that will be considered as universal set. Now the second set is union of sets. So union means combining two things. Okay, in general, if we see the English meaning, and this union is represented by U. But in sets, the union of two sets mean it is a set of all those elements which are either individual or both in common. That is both. If you see here, for example, as I said you, this Venn diagram is represented by a rectangle, and then here we have two circles. So this rectangle is nothing but it is mu. That is, it is consisting of all the elements. Okay. So in Venn diagram, always you will have a rectangle, and in that rectangle at the top right corner you have to write mu, that is universal set. Then if you want to write two sets, this circle A is set A and this circle B is set B. Now this pink lines are nothing but they are set A, and this blue lines are nothing but they are set B. So if you observe here, this circle is also a part of this, right? This section, and this circle is also a part of this section. That is, here if you observe in this section you have pink and blue, both the lines. That is, we can say A and B are sharing a common piece of section, right? So union is nothing but individual, okay, or both in common. So this union of sets, they can be represented by Venn diagram. So how to write that? This set A union B is equals to X is to X belongs to A, or X belongs to B, or X belongs to A and B. There is either, what is X here? X is any element which is present in A or B. We will see that in the future videos of how to solve the problems. Okay. So if the X X can either belong to A, or X can either belong to B, or X can belong to both A and B. That is nothing but union. That is individual or both A, B, or both A and B. Remember this. This is union. Now the third one is an opposite of union of sets. That is intersection of sets. We know what do you mean by intersection? When two things are combining together, there is something is common between two sections. That is called as intersection. Okay. So in intersection, we don't have anything individual. So as I said, you intersection is opposite of union. So the symbol of union was U, and the symbol of intersection is what is a reverse U. So if you see here, the intersection of two sets A and B is nothing but it is a set of all those elements which belong to both A and B. That is, this pink section, if you see, it is common to A as well as B. So A intersection B means that section which is common to both A and B. By the name intersection only we can see there is something which is intersecting, something which is common. So this is the Venn diagram here. So A intersection B is equals to X belongs to both A and B. Now coming to disjoint set. Disjoint set is represented by the symbol phi. Okay, so two sets are said to be disjoint if they have no common elements. That is, when set A and set B do not meet together, they are separate, they are not friends. You can consider like that. Then they are called as disjoint sets. Here, I have drawn I've shown the colors green and pink so that to know A is separate and B is separate. Okay, they are not joined. So that is why they are called as disjoint sets. This is how we represent disjoint sets in Venn diagram. Okay. Now, if you want to write this in terms of sets, that is formula A intersection B is equals to 5. Now, why am I writing this disjoint set as A intersection B is equals to 5? Because are they intersecting? They are not intersecting. That is why A intersection B is equals to 5. I said in my first video of sets, lecture 1, that 5 is used to represent empty set. So, if you observe, are they meeting together? No, they are empty. They are not joining. That is why 5 is empty. That is why A intersection B is equals to 5 is disjoint set. Now the last type of set is difference of sets. Now what do you mean by difference? You know, difference is minus. So if you have two sets A and B, okay, there are two cases in this. If you want to write A minus B, then we can consider that the section which is common only to A but which does not belong to B. This symbol is does not belong and this symbol is belong. So here x is to x belongs to A and x does not belong to B. Suppose an element is there. 1, 2, 3, 4 is there in A. Okay. So 1, 2, 3, 4, I'm writing only in this section of A. That is, the red lines indicate only this section of A. If I see this section is not included here and it is not in B also. So A minus B is what? A minus B is only A. If you observe here, that is, x belongs only to A but does not belong to B. So A minus B is only A. Now coming to the second case, what is B minus A? Then similarly B minus A only belongs to B if you observe. Oh, the section is only for B. It is not common also. Okay, so remember this. In difference, you do not have any common section and do not have any other set also. Only one set will be there, and which will be there? It is very easy to remember. A minus B. Always the first one is the answer. So A minus B means x belongs to only A, the first one. Similarly here, B minus A means it belongs only to B but does not belong to A. So B here is the first one. So hope you have understood all the different types of sets. If you did, please like the video and share the video with your friends. Thank you.